All right, we're looking at the guided notes for scatter plots. A graph of ordered pairs that relates two different sets of data is called a scatter plot. Really what you need to know is that we are plotting points on a graph. So looking at these examples here, what we see is as the x values get bigger, our y values get a little bigger with this random set of data that was given to us. Now the one in the middle here is comparing grip strength with arm strength. I don't know where they got the numbers from and the data in this graph, but there's no real correlation. There's nothing that really relates these guys together. On the last one here, in the state of Nevada, as your elevation increases, the mean annual temperature, the average temperature, seems to decrease. And that would make sense, right? The higher up the mountain you are, the colder it's going to be, right? So this we can see has a negative correlation. And when I use these words correlation here, we describe the graph of scatter plots by their correlation. It simply says how well the variables being graphed are related. So a positive correlation looks like if you were to put a line there, then you'd have a positive slope. Right? And if we were to put a line in this middle one, we would have a negative slope. And if you tried to put a line here, there's no way we would have a really accurate depiction of the data. So in the situation where they're kind of like all the points are scattered all over the place, there's no real correlation at all. So we would say there's no correlation. I don't want to introduce you to the languages, but I can. So here, on the back side now, how do we use the data? Well, we're going to take the following table of values and plot each one of these points. Well, first we need to determine what's going to be x and what's going to be y. So let's let the dollars spent, let's let that be x, and the gallons bought, let's let that be y. All right, once you know what your x and y values are going to be, then we need to put our scale on the axes here. So down here we have dollars spent, and those are just whole numbers. So let's go, let's say that's going to be 1, 2, 3. Well, I don't want to do it like that. Let's do this. Let's say we have 5, 10, 15, 20, 25. Way out here would be 30. Now over here, I'm going to break this up a little bit more. So right here, it's going to be a 1, and here we have 2 and 3. So it's going to go up in a matters of 0.2. So 0.2, 4, 6, 8, and 10. 1.2, 1.4, 1.6, 1.8, and 2. So let's take the first set of data here. My x value is 10. My y value is 2.5. So here at 10, I go to 2.5, and I'm going to plot that point. Now 11 and 2.8, so we go to 11, and then 2.8 would be this point right here. 9 and 2.3, here's 9, and then 2.3 is going to be halfway between 2.2 and 2.4, so we have that plot right there. 10 and 2.6, well, that's going to be this point right here. 13 and 3.3, 10, 11, 12, 13, and we go to 3.2, 3.3 right there. 5 and 1.3, well, here's 5 and 1.2, and 1.3 is going to be between those two. 8 and 2.2, here's 8. There's 2.2 is right there. Now we have 4 and 1.1. Well, here's 4, and 1.1 is going to go right in between 1 and 1.2. All right. Well, now we can start to see our graph here. We've plotted all of the points, and now we can see this is starting to take on a linear pattern, right? So it's going to look in the form of a line. Well, I don't know exactly which line yet, but it would be something along those, something like that, right? That kind of goes through the middle of all the data. A line that looking something along those lines. So, Mr. Thornburg, you make me nervous when I do these things.
Sorry.
It's okay. I just hate stuttering on these. You know, you just seem unconfident and ill-prepared whenever you do this, especially if you're in a hurry. Man, I tell you what. All right, so now, if we look down a little bit further, we have some questions that we can answer about this. We can create a trend line, using the data that has been provided. So we simply take two of the points, and we're going to use those 2 points to create our trend line. So I'm going to use, let's use this point here, and let's use this point here. And what we're going to do is we're going to create a line. And this is the point 5, 1.3. So we have 5, comma 1.3. And the other point is 13 and 3.3. So we have 13 and 3.3. So now what we could do is find our slope, right? And our slope is going to be m equals, now the change in y over the change in x, our y values are 3.3 and 1.3, so we have 3.3 minus 1.3 over our change in x, 13 minus 5, so I have 13 minus 5, and this gives me 2 over 8, which is 1/4. So once we have our slope, then we could use one of these points, right, and put it into point slope form. So we're going to have y minus, and I'm going to choose the first one here. So y minus 1.3 equals our slope, 1/4, times x minus 5. And we've done this a bunch so far. So now we can distribute the 1/4 over. So we get y minus 1.3 equals 1/4 x minus 5/4. And now we add 1.3 to both sides, plus 1.3. And I'm going to need a calculator. All right. So now we get the equation. This is the equation of our trend line. The equation of our trend line is y equals, well, since we're in decimals, let's keep it in decimals. 0.25x plus 0.05. So this is our trend line. And then we're going to take that and we're going to predict the amount of gas we could buy if we have $7 and how much we can purchase if we have $15. So if I plug a 7 in here, then it should be able to tell me what I get whenever I have $7. How many gallons of gas I can purchase for $7. Goodness gracious. I've never been this awful. And 7 times 0.25, well, 7/4 is, what, $1.75? So we get 1.75 plus 0.05, which gives us 1.8. So I could buy 1.8 gallons of gas if I have $7. Then it asks us to use the prediction equation to find out if I had $15. So if I have $15, how many gallons of gas can I buy? So I say y equals 0.25 times 15 plus 0.05. And 0.25 times 15 is 3.75 plus 0.05, which gives us 3.8. So if I had $15, I could buy 3.8 gallons of gas. And that would be close to right. It would be somewhere up here in our graph. So that looks like it's part of it. So let's look at some of the other terminology that we have here. Interpolation. Right, that's kind of a mouthful. Interpolation. Estimating a value between known values. So of the two that we predicted here, we we had when x equals 7 and when x equals 15. Well, 7 was somewhere in the middle of our data, right? It was somewhere right in here. Somewhere in that ballpark. And then if we look at extrapolation, right, predicting a value outside the range of known values. Well, our range of known values is between 4 and 13. Right? But we wanted to calculate it whenever the x value was 15, so this would be an example of extrapolation because it's outside of our range of values for the table. 7 would have been in the middle of our range. 15 is definitely on the outside. So this is an example of interpolation when x equals 7, and when x equals 15, that's extrapolation. And we'll discover more about that in class tomorrow.